Cool. So you get 2, give or take. 4 plus 24 is 28. What can you do with this? So it's 4, 7. So square root of 4 is 2. Square root of 7 I don't know. And then the 2's can all cancel, right? Remember, I said you can't break it to a plus or minus, but they all work. So that's when it's, because you can take a 2 out, 2's cancel. 1 plus or minus square root of 7. Don't circle that and go on, because that's equal to u. And the original question is all about y. So if u equals 1 plus or minus square root of 7, u was
square root of y.
Square root of y.
You gotta cube each side, or square each side.
I like it. Square each side. Now this is where you're going to hate life a little bit. Well, let me see if I can tell you something right here. I want to make this a little bit easier on you. Even using complex numbers, can the square root of something be negative? No, because it's understood to be the principal root, right? So right here, is there an answer on the side that is negative?
Yes.
Think about it, be careful. 1 plus root 7 is obviously positive, because everything's positive. What's 1 minus root 7? Do you know exactly what it is?
Negative.
No, but you know it's negative.
Yeah.
How do you know it's negative? Because square root of 7 is bigger than 1. So when I do 1 minus it, it's gone. So can't I throw something out right now? I know it's not going to work.
Negative.
So see, this guy right here is saying 2 things. It's saying that square root of y equals 1 plus root 7, and it's saying square root of y equals 1 minus root 7. This we know is crap. Because square root can't be negative. All complex numbers do for me is it says, oh, there are some things you can square to be negative, but the square root still can't be negative. So that makes it a little bit easier on us. Do you agree? A little bit. Now, if you did all the work here, you'd have to FOIL something out twice. That's why I was trying to save us some time. And then one of the answers you get wouldn't work. A bunch of work for nothing. If you take a second and see square root of y equals, it can't equal a negative number, let me throw that one out right now. Save me some time. Now, what's the next step? Like Tamara said, do square both sides. She sounded very excited about it. I'll do this side. I did my half. Now you guys do that side.
This is 8.2.
8.5. Just remind you guys, 8.4 was never on our plate. And 8.3 I've made extra credit. 8.3 is really just word problems with radicals. So I thought I'd give you guys a little break.
Tomorrow's quiz is 8.1 and 8.2.
Yep. So you guys get 1 plus a couple of these, right? Plus 7. So you get 8 plus a couple of these. All right? Is that cool? So there's your one answer. Why does it make sense there's one answer? Say honestly, it doesn't have to be this way. Highest power here is 1, but it's not really a polynomial. Why is this not a polynomial? Yeah, it's got the square root. That's a 1/2 power. It can only have whole powers to be a polynomial, right? So kind of all bets are off if they're not polynomials.
Just like if they're fractions. If there's a fraction.
Oh, if there's a fraction.
Wait.
Yeah, exactly. Yeah, it's got to be whole number of powers. Yeah.
Where did the 8 come from?
I get 1, and then a couple of these, and then 7 times square root of 7 times square root of 7 is 7. So
Okay.
that's just putting the 1 and the 7 together.
Okay.
Cool. Okay. Let's try one more of these. Just to show you, it doesn't really matter. Yeah, here we go. Man. Oh, I think, oh, cool. Every single one they give you like this seems to be factorable, so that's kind of nice of them. Now again, and the U thing is not necessary. It just makes it easier to look at. So if you're someone that doesn't need the U thing, doesn't like the U thing, don't do it. I don't care. It's just a tool to make it easier if we need to. So here, this almost looks like x squared minus x minus 6, just got negative powers instead. Here, I really probably don't even need the U thing, do I? What would x to the negative 2 be? What would I put here and here? Yeah, x negative 1, x negative 1. Because when it's x to the positive 2, I put x to the positive 1, positive 1. To make positive 2. And then negative 6 to make negative 1. 3 and 2. And the 3 is negative. Cool. Because you always try to factor it first, right? Always. Don't jump right into quadratic, because if it factors, it could be a lot uglier to do quadratic. So then what's got to be true? X to the negative 1 equals 3. Or x to the negative 1 equals negative 2. Cool. Now what the hell do you do here? Here's a really funny thing. What does the negative power mean? Flip it. So this is really 1 over x, right? Okay. And here's what's funny. What do I want to do to this just to make it x? I just want to flip it. So if you whatever you do to one side, you better do to the other side. Another way to look at it is, how do you kill a negative 1 power? You raise it to a negative 1 power. Because what happens? Negative 1 times negative 1 is positive 1. Do it to both sides. 3 to the negative 1 is 1/3.
Minus 2.
Oh yeah, minus 2. Cool. So they give you a few like this. I've been noticing from the answers that none of them look like they need quadratic formula, thankfully. For these get a little excessively weird, so they decided not to throw a quadratic formula on top of it. Let's see, blah, blah, blah. So, I mean, they could do this to you. Let me make it the same as that, just to keep myself. Where'd it go? Oh, there it is. 2 and 8. These are in this section because they're all about being quadratic in form, right? This guy squared is this guy. Right? When you square y to the 1/3, you get y to the 2/3. So again, I mean, this is nice. What am I going to put there and there to split this guy up? 1/3, 1/3. How do I do negative 8 to make negative 2?
Negative 4 plus 2. 4, 2.
Cool. So y to the 1/3 has to equal what? Equals 4? Or y to the 1/3 equals
Negative 1.
negative 2. And then how do you solve for y? Raise it to the 3rd power. I love it because this is currently a cube root. This is currently a cube root. How do you kill the cube root? 3rd power. Because see right here, cancels. So y equals 64, or y equals negative 8. Cool. Okay. I think, yeah, okay. Be real careful in my radicals. I didn't even check this. I should have said the fact, Why do I know this is okay? Because the original equation had a square root of y in it, and that's positive, right? But whenever you have a radical in your equation, you've got to check the solution, make sure it doesn't make it undefined. Or in this case, it'll be complex. So that'll be fun. Okay, they don't get too much worse than that. Yeah, let me let you guys try one of the ugliest problems in there. There it is, okay. Will this, oh yeah, definitely. Yeah. Trust me, if you take pre-calculus, just about all the algebra you're learning, bless you, can show up anywhere in that class. So it's, yeah. So at least there's a purpose for this.
Who decides to make us insane?
That's always there, but yeah. Yeah, so you
Plus 5 minus
cool. Alright, so you could use quadratic, you don't have to because it factors. So you get u is possibly -5, or u is possibly 2. So what was u? 3 plus radical x equals -5.
Oh, wow, I did not do that.
What's up? How far did you get? Did you get here? So it's -5 and the 2?
No, I didn't do any of that on the top left.
What happened? What'd you do? Did you FOIL this out? Oh, okay. You could do that.
Oh, I did that too.
Now notice right there, what do I know?
Square.
No, right there, what do I know?
It's not true.
Never going to what? Right, square root cannot equal the negative number. Cool. So I know you get 64, but if you plug it back in, it doesn't work. Because the square root of 64 is 8, not -8. You see what I'm saying? So whenever you have radicals in your equation, you do have to check to make sure that the signs come out correctly. Yeah. So u equals 2 could possibly work. So you go back in what u was. U was 3 plus radical x. Subtract 3, radical x equals -1. Oh shit. No solution, exactly. So the only 2 possible solutions don't work. Now let me think. I was thinking earlier about showing you a really simple little example of this u thing and what it really means, right? Because I still can see some of you guys, and I know on one level you guys are saying, "Oh, how is it possible you're allowed to do that?" I know you're still saying that. Why are you allowed to do this, right? And I keep saying the lamest thing I know is, do you know what 3 plus radical x is? No. So let's call it u, because that's what we do. We give a letter name to things I don't know. But you're like, all right, that's not good enough, Jeff. And I understand. Go with me on this. 2m plus 1 equals 5. Right? Let's make it x. Let me not make any freaky letters there. 2x plus 1 equals 5. Just tell me this. Tell me this. Just looking at it, what's got to be true about this? 2x. To add 1 to it to get 5. That has to be 4, doesn't it? So couldn't I say, okay, what is 2x? I don't know. Let me call it u. So you're, in effect, you're solving first for the 2x. But where's 2x? It's right there. So when you say -1, u is 4. So that's what this has got to be. Then you bring back in 2x to see what x has to be itself. We're doing the same thing over here. We're saying, whatever's in here, what's that got to be? Oh, it's got to be -5 or 2. And then you go, okay, let me break it down. So that was this. Let me solve for x now. So that u is kind of like a placeholder saying whatever the hell is in this place, what's it got to be, this or this? And then you pull back in what it really is to figure out what the x has to be. I mean, hopefully, it sounds like at least a couple of you guys kind of got what I'm saying there. I think it's possibly the best I've ever explained that. So you guys are like, you still got to get better, dude. All right, I'm trying. Okay. I like that. I like that you can say it's a great explanation, but I still don't understand it.
Well, I understand the concept, but I would never ever think of doing it like that. So.
Oh, believe me, there are a ton of things I see all the time that I'm like, I would never have thought to do that, but it works. I mean, I don't care if you would never have thought to do this. I can totally understand that, because the people that came up with this are the people whose life was mathematics. So they had some more time they were devoting.
My question is how would you do it if you didn't think of it?
Well, you do it like Tamara's doing the other one. I'm not picking on you. I'm just saying that's not a bad way to go. You can FOIL this out. And that's the one you're doing, right? FOIL this out, distribute that, get your like terms together, isolate the radical, square both sides, right? Sure. There's almost always more than one way to do something. It's just that if you notice that the same thing is repeating over and over, try to use substitution and see if you come up with a nice form that you can do easier. Right? Instead of FOILing this out, like terms together, all that kind of crap. Okay, maybe.
Can you explain the u substitution one more time?
I don't know.
I think I get it when it's there in that equation. And I can use it.
I really was honest when I was saying that was the best I could do, at least at the moment. So I got to think about it. Yeah.
Okay.
It works here because you know it's half or double, right?
Yeah, but U sub goes beyond that. U substitution, if anybody has to go to calculus. Anybody here have to go to calculus? A few guys. U substitution will be your best friend. Believe me. Not at the beginning, at the very end. U substitution, you know already. So you know what I'm talking about? U substitution will be awesome. It will take this ugly monster, ugly freaking, ooh, and then, oh, it's pretty, yay. Right, that's what it will do. And it's sort of like what it does for us. It's still ugly, it's still sort of ugly, but it's definitely a hell of a lot better to look at than that. On one level, all it's doing is saying, I never solve for x first, do I? Right? In fact, even here, what's the first thing we do?
Move the one.
Yeah, so I solve for this thing. Does it matter then on the first step what is sitting here? Couldn't I just put a question mark there? First step is the same. And then I say, okay, question mark is 4. What was question mark? Oh, 2x. Okay, so 2x equals 4. Now keep going, right? So sort of saying, I just want to solve for what the number would have to be that goes here first. So what is the number that's going? I'm going to call it u. And then I'll go, okay, now what does x have to be to make that number? That's then the next step, the next level of the u sub. Okay, all right, that's all I'm going to say about the u sub. Okay. Let's see. Those are all basically the same. Trust me, the first thing you want to try is factoring. You don't go straight to quadratic on these. Right? Try to factor first. That'll be a lot more direct. Okay. So, I didn't bring my graphing calculators, but that's okay, because they really just want to show you on the overhead a few things about parabolas. Let's see. So let me actually do a couple of lines with you first. That didn't sound right, but I was waiting for the reaction. If I had y equals x, what's that going to look like? What's the y-intercept? Slope is 1 over 1. Y-intercept is 0, right? Goes up 1 over 1, up 1 over 1. You can go back 1, down 1. So I end up with this line here, right? If you had to describe, not graph, but describe to me how that would look in relation to this, what would you say? If I knew what this looked like, and you weren't allowed to graph it, you just had to tell me what this looked like.
It would be parallel.
Parallel, be more specific.
It would be parallel. 3 steps up.
Yeah.
Above it, right? It's as if I took this line, picked it up,
And moved it 3 steps.
and moved it up 3. And that's really what it says. It says take what it was and make it 3 bigger everywhere. So everywhere it goes up 3, right? Some of you guys might know where I'm going with this, maybe. Now, what about if I were to do this? What about y equals 4x?
It is.
It still goes through 0, 0, but now it's going to rise and fall quicker, right? Because now it's going to go up 4 over 1, but you're not allowed to graph it. You got to tell me. So it's going to be like this line turned up. If I put y equals 1/4 x, it's going to be like this line turned down. You guys with me? All right, cool. So that's basically everything we've done before. I just never said it quite like that. And we're slowly sort of stepping into what's called translations, where I can just take something and move it somewhere, move it over, move it up, right? Okay, so what I'm going to do, let's graph first, just a regular old parabola. Good old x squared. Let's do zoom 6, make it nice. There it is. Cool?
What did you put in there?
X squared.
That's it?
Just y equals x squared. And then zoom 6, you remember, anytime I put new stuff in, I hit zoom 6 to kind of start me off at 10 by 10. There it is, nice. So can somebody tell me, what do you think is going to happen if I put y equal x squared plus 3?
It just moves it up 3.
Yeah, it's going to move up 3. It's going to take that whole parabola, and every x squared, whatever x squared used to be, is now going to be 3 bigger than that. So now it's everything, every single point is going to go up 3. So it's just like taking the whole graph, moving it up 3.
You left the original and then put that in y squared or y2?
Yeah, you can
draw
still do
both.
that. Yeah. I didn't want to get too much stuff on it because I'm going to do several things. But we can certainly leave that in there, x squared plus 3. So there's the original, there's the new one.
What?
There's one place where Casios have it over TIs, because Casios can actually do different colors for the lines, which is nice. Now, obviously, if I were to put instead a -3, the whole thing just goes down, right? Now, how in the world do you get it to move? Oh, before I get too far, let me talk about the other thing we talked about over there. What if instead I put 4x squared? So here's my parabola, right? Can somebody imagine what it would do if I just put 4x squared in there instead of x squared? Be careful, that's what you might think at first. But y equals x squared. If x is 1, what's the output? Y equals x squared. If x is 1, the output is... Right. So if I have y equals x squared, if x is 1, y is 1. If I have y equals 4x squared, if x is 1, y is 4. So here's a regular parabola. At 1 it goes to 1. Y equals 4x squared. At 1 it's got to go to 4. So parabola actually gets skinny or narrow. Yeah. It's hard for me to say narrower. Narrower. So I like the word skinnier. Skinnier. So 4x squared should be skinnier. There's the original. There's the skinny dude. Right? And it should go along with what we know. For a line, that 4 would be the slope. That 4 is still sort of related to the slope here, so it's a bigger slope. It should go up quicker. So if I make it 1/4 x squared, that's when it gets fat. Right? So we'll go back in and make it 1/4. Oh, you just did great stuff. I'm awesome. Got it. So I'm going to make it 1/4 x squared. Bam! Big old fat parabola. Cool. Which it goes on exactly with what we know about lines. 4 is not the slope. A real quick word about that. Why could 4 not possibly be the slope? What's happening every time I move on this parabola? What's happening to the slope? It's getting bigger on that side. Over here, it's getting more and more negative if I go that way, right? So there is not a single slope for this. The slope is like always changing. That's why it turns. Line never changes, right? One big thing in calculus is you guys actually calculate the slope for a parabola. It would have to be a function. Oh shit, enough of that. But it's still the same thing though. When I put a big number in front, it should make it rise quicker. When I put a smaller number up front, it should make it rise slower. Same thing as we know before. How in the world then? So far so good. Are we good? So in general, let me try to generalize this. What we know so far. And this is not just for parabolas. Do you guys realize that? I mean, if I had a square root of x, that would look like this. If I have square root of x plus 2, what would that do to this? Pick it up 2. So it does not matter what the function is. If I have a function, f of x, then f of x plus, let me use the same letters we do, plus k would make it go up or down k. If k is negative, it's going to make it go down. If k is positive, it's going to go up. A times f of x, if a is bigger than 1, it's going to make it rise quicker or fall quicker, depending on what it's doing. If a is 1/3, some number less than 1, it's going to go slower. It's going to be fat for parabola. It's going to go up or down slower. How are we doing so far? And it's basically stuff we already knew. So how in the world, if I got my normal parabola sitting there, how do I make him move left or right? And we actually have done this before. Let me remind you guys. What's the domain for this guy? And you can kind of see it in the graph. What's the smallest x we're allowed to plug in? 0. Square root of 0 is 0. We've done it where it went back here somehow. And we've done it where it was up here somehow. So we have moved it left and right somehow. We didn't do it ourselves. It was just a problem they gave us. But how in the world do I change the domain for this guy? If I want to be able to plug negative numbers in, what better adjust for that? If I wanted to plug like a -1 in and keep it real, I better put what in here to kind of counteract that?
Plus 1.
What do I get when I plug a -1 in now? 0, and that's allowed, isn't it? For a real, remember we're graphing, so it's got to be real now, right? Unless you want to graph complex numbers.
Not really.
Good. So this guy is square root of x. Y equals square root of x plus 1. Now this kind of sucks a little bit, I understand, but the nice thing is, if it's inside with the letter, you make it the opposite. What makes this 0? -1. So everything's going to move back 1. And if I make it, because now, think about it like this. Since I'm adding 1 before taking a square root, I'm allowed to have 1 less than I was allowed before. Right? That's why the domain moves back 1. Everything can be 1 lower than it used to be. If I had minus something, then everything's got to adjust for that. They all got to be bigger than they had to be before. Because I'm subtracting something from the radical. If I had x minus 3, the lowest x I can plug in would be 3. So that's why it moves up 3. Okay, so if I wanted to make this parabola sit on -4, what would I have to do to the equation? I'm not doing square roots, I'm doing parabolas. So it would be x plus 4 squared. Do you see how the plus 4, if it was outside, if it was x squared plus 4, it would move up or down. In that case, it would move up. If it's inside with the letter, in with the x, what's the x-axis do? It goes left or right. So it's in with the x, it's going to go left or right. And sure enough, there it is. Pop, moved back 4. Okay. Maybe. So, what we just learned is interesting. We just learned that f of x minus h will take f of x, whatever f looks like. In this case, it was a parabola. And we'll move it either back h or forward h, depending on what sign h is. Right? The reason it's minus h is if it was 3, it would move it up to 3. Right? So it would move it over. If I had x plus 3 squared, it would move it back 3. If I have x minus 3 squared, it actually moves it up to positive 3. Cool? Okay, maybe. So here's the interesting thing. Let me see if you guys can get this. What is the vertex? Let's start off with the normal one. What's the vertex for this? What does the vertex mean? What does that mean for a parabola? That's also known as the turning point, right? Either the lowest point or the highest point. What is that point for just the regular parabola? 0, 0, right? Because that's where it's sitting. It turns right at 0, 0, right? It says, I'm going negative. Oh shit, I'm not allowed to. Okay. So 0, 0 is the turning point. That's the vertex. What is it? What would it be for this? Which way would this go? To the right. So this would look like, here's your normal one. It would move over 4. See if you guys are with. It's going to move over this way 4, right?
And then up 5.
And then up 5. So actually it would be sitting right there, just about, roughly. You know, it'd be perfect there. So the vertex would be at 4, 5. So this is interesting. If my parabola equation is in this form, the vertex jumps out at me. Sort of like when you solve for y, the slope and y-intercept of a line jump out at you. In fact, you see this happen a lot in mathematics. If you put it into a certain form, whatever the thing is you're dealing with, things about it jump out at you. A circle, if you put it in the right form, its center and its radius jump out at you. You can just look at them. There they are, if you put it in the right form. So if I put a parabola in this form, the vertex jumps out at me. Cool. Yes, sir?
Why'd you do the f of x minus h? Just to show that you could put whatever you want in for h?
Yeah, exactly. Because h could be positive or negative. Yeah. And the reason I put the minus in that equation is because if h is 3, it does go to 3. Right? So here's just the full picture on what we know so far about parabolas. Let's stick with parabolas. So for parabola, if it's in this form, so real quick, can somebody tell me, for this one we just did, what would A be? 1. There's a 1 here, right? What would H be?
4.
And what would K be?
5.
I love it. So what is HK? What's that? That's the vertex, right? So the vertex just jumps out at you, whatever that is. That's the vertex. And if A is less than 0, what's the parabola going to do? It's going to open down. And if A is greater than 0, it's going to go open up. And of course, we know if A is like 4, it's going to be skinny. If A is 1/3, it's going to be fat. Right? You guys like, sure. Yeah.
So let's say x plus h, would h be negative?
Yes, exactly. H would be negative. Right? Cool. So let's do this. Can you guys give me an equation? I want the vertex to be at -2, 7, and I want it to be fat. I'm not being specific there. You just have to give me some number that will work. What would I put in here to make that work? I like it. So +2 in here, right? Because like you just said, what does it mean h must be? This must be x minus -2. It must be a -2. And really, I don't get into all that crap with a minus and negative. It's just always the opposite of this. And we're used to that, right? If I want to divide by x plus 2, what do you put in the little penalty box? -2. The thing that would make this 0. Right? That's kind of nice. So that would make the vertex -2. How do I make it 7? For the y piece. Plus 7. And how do I make it fat?
3.
Careful. That'll make it skinny because it would rise quick. I want it to rise slow, so maybe 1/3. So let's try it. Let's put that in the calculator. See what we've created. Our creation. Is it reading? I won't sing. You don't want me to. So 1 divided by 3, right? X, what do we say? Plus 2 squared plus 7. There it is, right? Where's the vertex? It's going to be at -2, 7. It's fat, right? I can check the vertex by doing the minimum. Let's do that. I know all of you still don't have your calculator, so I'm just going to kind of go for this. If I find the minimum here, that of course would be my vertex, right? So go to the left, go to the right, get right on it. Remember what I said about this? It's trying to say -2? Okay, it's just doing the best it can. Poor little dude. How are we feeling about that? So the funny thing is, that whole translation thing, the f of x plus k and all that kind of stuff, works for any function. We're going to talk specifically about parabolas in this section, which is nice. But in pre-calculus, those who are going to go to pre-calc, you're going to use the hell out of those translations, and you're going to learn more than what we've learned. You're going to learn how to reflect them. You're going to learn how to smush them. All kinds of weird stuff.
Is it a lot harder?
It's just a lot more. I mean, it's the same idea. It's just that there's more stuff to realize what it does to a function. Like we haven't talked about how do I take that and make it flip down here? We're not going to talk about it. But it's not that hard. Okay, so let's look at some of the homework in this section so we see what the hell they expect from us. Like page 655. I didn't assign any of these because I wanted to do them in class. So that's perfect. Look at number 1. Number 1 has this. Turn this guy off here. Now I know the quick way to do these match them up questions is to graph the damn thing and see what it looks like. Match it up then. But number 1 on page 655 says this: f of x equals 2 x minus 1 squared plus 3. Tell me everything you know about this parabola. What's one thing you know?
It goes up.
It goes up. I love it. So it looks like that. Up. Is that all we know? Yeah, the vertex. 1, 3. It's going to be fat or skinny? Careful. Skinny. It's going to go up faster than just 1. So it's going to become skinny, narrow. Right? Skinny. Do you see anything that fits the bill there on the page? So all the ones that go down obviously are out. So H is at 2, I'm sorry, what do we say, 1, 3. It opens up. One last thing we can do is, what's the y-intercept? How do you get the y-intercept for anything?
3, X0.
Make x, be careful, it's not 3.
3.
It's not 3.
No.
How do you get the y-intercept for anything? Make x 0. 2 times negative 1 squared is 2 times 1 is 2 plus 3 is 5. Does h have a y-intercept of 5?
Yes.
Sweet. So h is it. Be real careful. I know we're used to like this equation. What's the y-intercept here? 5, because these go away. Right? If I make x 0, these go away. If I make x 0, does this go away? No. X just becomes 0. That becomes negative 1 squared. Be real careful about making sure that you can take the last number because these go away. If they don't go away, oh shit, you better work them out. Okay, and I know you can always check yourself by just plugging it in and looking at what it looks like and comparing, but try to know ahead of time. You can tell me all this stuff by just looking at that form. That's crazy. So let's see another one. What about this one? Negative 2 x plus 1 squared plus 3. So it opens down. Vertex is beautiful, right? What's the vertex?
-1 and 3.
-1,
And
3. It's going to be skinny again. Yeah,
How do you know it goes down again?
because it's negative. Yeah. If that first, and it's the same idea as slope. Negative slope goes down. Positive slope goes up. So it's awesome. Negative slope for parabola goes down. For other graphs, it's a little hard to know what up and down is. Then it just kind of reflects it. But for parabola and for a line, it's awesome. Up, down. Can't beat that. Vertex negative 1, 3. They're all going to be a factor of 2, it looks like. So they're all skinny. Right? And what's the y-intercept here?
1.
Yeah, negative 2 times 1 squared is negative 2 plus 3 is 1. So the y-intercept, 0, 1. I like it. So then you can figure out.
How do you get 1 again?
Plug a 0 in for x. So you get negative 2 times 1 squared is negative 2 plus 3, 1. Cool. Trust me. The easiest thing for people to forget is how to get any intercept. How to get any intercept? Make all the other letters 0. Whatever level of math you're in. Make all the other letters 0. We normally only have 2. You can have more. Okay.
Where did that come out to? B?
Oh, I'm sorry, yeah. Which one was it? Negative 1, 3. It's opening down. Negative 1, 3. Yeah, it looks like it could only be, which one? B. That's the only one that goes negative 1, 3, opens down. The y-intercept is 1. Bam. Can't escape. Cool.
What number was that?
Oh,
It's fat, right?
that was number 5? Yeah. Okay. Yeah, they can't really beat it. There's one last thing I haven't talked about yet, but they're basically all going to be identify the vertex. Is it opening up or down? You could find the y-intercept also. So let me give you this. One last thing I haven't talked about yet. And I wish I would have talked about it, because now I've got to redo a whole problem here. But if I had this, huh?
This fat or skinny? Fat, right?
Let's make it like that.
This fat?
Which one? This one?
Yeah.
Skinny.
Skinny?
Skinny, yeah. They're all going to be skinny. They're all basically a multiple of 2.
Oh. Minus?
Yeah, but minus just makes it open down.
Up and down.
Yeah. So it's a fat parabola that's fallen over.
Okay.
Right. So if I have this, where's my vertex at?
5.
Right? And it opens
Um,
up. So let's see this. So 5. I had to go and pick one that was like that. Give yourself a lot of room like that. 5, 1. Here's my vertex. It opens up. It's going to be kind of fat, right? Here's the cool thing about this. Yeah, Jeff. You had to go and make it. Oh, well, this will still work. What's the y-intercept? Well, it's building 0, negative 5 squared is 25, divided by 2 is 12.5, plus 1 is 13.5, right? That's not too bad, right? 13.5. Let me make this, oh crap. What a beautiful example, Jeff. 2, 4, 6, 8, 10, 12, 14 there. So 13.5, so it's right there. Cool? I want to show you a nice way to graph these things. Do I have enough points to really graph this? Not really, right? I know we need at least 2 for a straight line. You should have at least 3 for a parabola so you can see where it is on both sides. I have the most important point, the turning point. The second most important point, the Y-intercept. Who can tell me something interesting about parabolas that makes another point easy to find? Yeah, it's symmetric, right? So if there's a point that's 5 back and up 13.5, there's got to be a point that's 5 up.
10, 13.
6, 7, 8, 9, 10, and up 13.5. You guys with me? So this point we got because it's the Y-intercept. This point we got because it's part of the vertex. This point we got by symmetry. Kick ass. Will you always have a Y-intercept for a parabola? Why not? What kind of parabola are you talking about? A parabola that opens up or down, yes, you will always have a Y-intercept. Because the parabola will cover the whole x-axis. It's going to have to hit the y-axis sometime. The only way, do you guys understand? If it's really skinny, it's still going to hit it somewhere way the hell up there. It's always moving over a little bit, right? That's what a parabola does. It never goes straight up. It's always got to intercept that y-axis somewhere, unless it's opening sideways, which is not something we're going to do. That's what you'll do in pre-calc. Figure out how the hell to make a parabola open sideways. Right? Sideways. So now I can graph my parabola here. Yay! That's sort of good. All right. Leave it alone. I was trying this hard. Where would you say something called the axis of symmetry would be? Yeah, it's right where the mirror would go, right? So right here is the axis of symmetry. Can anybody tell me the equation of that line? X equals 5. It's straight up and down. X equals 5. So what is always the axis of symmetry for our parabolas opening up or down? Is always x equals the x-piece of the vertex, right? Because the vertex is always going to be that symmetric point. How are we doing? So if a parabola went through... so this is called the axis of symmetry. Every time I talk about that, I always remember that stupid axis of evil speech from a while back. But I think I just let off my political leanings. If I had something that went through a vertex of negative 11, 7, what would the axis of symmetry be? X equals negative 11. Cool. So the axis has got to be the equation of a line. I like it. Okay, okay. So you guys try this one. You have to graph this vertex, labeling all the important points, and identifying the axis of symmetry, right? So this is number... Oh, let me give you a good one. Oh, yeah, cool. Jeff, how geek can you be? Let's see. Number 51. So you got to tell me the vertex, Y-intercept, axis of symmetry, graph it by finding another point. So a point by symmetry like we did over there, right? Hopefully you understand what I mean there. We'll find out. And this is a really good preview of pre-calculus. What you guys are going to be doing are analyzing the hell out of a bunch of different functions, getting all this stuff about it, and then plotting it.